All right, class. Today we're looking at section 11.3, and the idea here is we're actually learning how to take care of rational square roots. Now, a rational square root is this idea. It says if a squared equals b, then a is a square root of b. All right, so that means if I had the square root of 81, well, we know the square root of 81 is 9, so it could be positive 9, but it also could be negative 9. And again, we saw that last time we played this game, because I know that 9 squared is 81, but negative 9 squared is also 81. So for every even root, square root is an even root, there's two answers, the positive answer and the negative answer. Now the idea here is the positive answer, usually it's this one, okay? They don't put anything in front of it, it's just understood that it's the positive root. It's the principal root of a. And then when they want the negative root, if you notice, they put a negative sign. Now we're going to use this together with our product property of square roots to help us with these rational square roots. Now, we've got the product property of square roots. And again, if I looked here, let's say you came into school one day and you were kind of brain dead and you had the square root of 36 and you, oh, Mrs. Burton, I can't remember what that is. Well, we know that the square root of 9 times the square root of 4, because 9 times 4 is 36. Well, that means we've got the square root of 9, which is 3, times the square root of 4, which is 2, and that equals 6. So it's just a way to kind of bust it up into smaller parts that help us. And then the idea of the quotient property of square roots is whenever I have a fraction, okay, inside the radical, we rewrite it as the square root of the numerator over the square root of the denominator. All right, so let's go through now and see if we can take care of some of these. Now, if you look at number 1, I want the square root of 64, and you notice there's nothing in front of it, so that means they want the principal root or the positive root, and so we would say, okay, square root of 64 is 8. If you look at number 2, did you notice there's a minus sign in front of there? So that means they want the negative root of 196. And so the negative root of 196 is negative 14. The square root of 196 is 14. Could be positive 14 or negative 14, and they want the negative root. Now, on number 3, if you notice, they put a plus minus in front. So this time they want the roots. They want both of them, plural. Well, remember, if it's a fraction, I'm going to put, rewrite it as the square root of the numerator over the square root of the denominator. Now, don't forget to put your plus minus sign out in front. The square root of 1 is 1, and then the square root of 256 is 16. And if we look at number 4, once again, they want the negative root this time, and we're going to rewrite it and put the square root of 225, the square root of the numerator, over the square root of the denominator. Don't forget your minus sign out in front because they want the negative root. The square root of 225 is 15, and the square root of 49 is 7. Now, we're going to get into some square roots that are a little bit bigger than we may know, and so a real good thing to help you as we go through this section, there is a chart in your book, okay? And if you need some help figuring out square roots, then you can check out the table on page 681. So go ahead and open up to that page, and let's see if you can use that table to find the square root of 576. Now, if you notice, they want the principal root, they want the positive root, and if you look that up on your chart, you're going to see that it is 24. On number 6, we want the negative root. Again, they've given us a fraction, so we take the square root of the numerator over the square root of the denominator. Now, both of those are pretty high. You may not know them, but if you look them up in the chart on page 681, we're going to see, don't forget the negative sign, and then it's 34 over 17 Now, did you realize I can simplify that fraction? Okay, so final answer here would actually be -2. Now, when we get to number 7, you're going to look and look for a 180 and 845 on your chart, and it's not there. So what we've got to do is we've got to come up with, see if we can come up with the GCF that we can factor out and see what's left. Now, if I look at that, if that ends in 0 and 5, if you remember your divisibility rules, that means they're both divisible by 5. So that means that I could take that 180, and it's actually 5 times 36. And if I look at 845, and if I divide that by 5, we're going to get 5 times 169. Now that's real important to see, because number 1, I've got a 5 in the numerator and a 5 in the denominator, and they can cancel out. And then I just need the square root of 36 over the square root of 169. Square root of 36 is 6 over the square root of 169, which is 13. And don't forget to put your plus minus in front. Now, when we look at number 8, a couple of ways I can do it. The first thing we can do, the easy way, is I could change that into a fraction. I can make that the square root of 9 over the square root of 100. Now, how did I do that? Because it's the hundredths place, okay? 9 over 100, and then the square root of 9 is what? 3. The square root of 100 is 10, okay? So you could say 3/10. Or the other thing you could see on this problem here is I know that 9's a perfect square. Okay, I know that 9's a perfect square. So, and I know that the square root of 9 is 3. So what I could say then is, because I have 2 decimal places, I need half as many decimal places in my answer. Remember, when we multiply decimals, we have to count decimal places and put them in our answer. So then, or you could say that this has got to be 0.3, because if you did 0.3 times 0.3, you would get 0.09. All right, so we're basically only working with the number parts today and familiarizing ourselves with some rational number square roots. And so then we're going to see that we can use page 681 to help us.